unsigned int. But just to be consistent with iOS practices, I gave it the NSU integer, which is just it's not a class, it's just a type def. It's a synonym for unsigned int. All right, I've got one for the left, one for the right. And bool for paused, I needed some variable just to keep track of whether or not the game is paused. And when does it seem to pause, based on our tinkering earlier? What's that? When it's in the background and also in the beginning, when the ball is just sitting there in the middle before I actually start interacting with the app, or conversely, every time there's a score made, then the ball goes back to the center and I have to touch it for the game to resume. All right, so now in the view controller, a lot of this now is just logic. So after initializing the object with the nib name, I'm initializing the score left and right to 0. I am first declaring a velocity. So a velocity has to do with motion, and yet you can represent it with a point. If a point is just x comma y, you can just treat the x as delta x and the y as delta y, change in x, change in y. So I just use the now familiar CG point make, velocity comma velocity, and this just means if it's 10.0, what did we say it was earlier, the constant? 10.0, this just means for every unit of time, move 10 points this way, 10 points that way, effectively going on a straight diagonal. All right, so what happens next in this initializer? This is how the game actually has motion. So we declare what's called an NS timer. We schedule it with a time interval of 0.05. So every 5/100ths of a second, I want something to happen. And I just decided on that by trial and error to see what would feel right. Targeting myself with a selector of play. So apparently, I want what method to get called every 0.05 seconds? The play method. All right, and beyond that, and it repeats in that if you recall from JavaScript, there's set interval and there's set timeout. This is like set interval, given that I'm passing in repeats a value of yes. So now what happens next? Nothing seems to happen there by default. Let me scroll down. There's a play method. A lot of math there. Touches move. So touches began. So it looks like what I'm doing here is when there's a touch on the screen, I am changing the value of paused to no. So this was my way of kickstarting the game. As soon as touches begin on the screen, doesn't matter where the human touches, that means kick the ball. Let's start the game of Pong playing. And I change that Boolean field. So presumably, my play method is going to check that value. So let's go into play here. And indeed, if the game is paused, just return immediately. Don't play anything. Don't do any mouse movements or cursor movements or ball or paddle movements. Otherwise, move the ball. So this is very similar behavior to before. Even though this is being called on a timer, not in response to user action, what do I want to do every unit of time? I want to move the ball how? Using its velocity. So if its velocity is 10, 10, every time the clock fires, I want to move it over 10 and up 10, if that's its current velocity. And that's what I'm doing. I'm making a new point, taking the ball's current x location, adding the velocity's x value, then comma, the ball's current y location, and adding the velocity's y value. But now I have to somehow detect when the ball is in the goals, as was proposed earlier. So what is this line of code saying? If self.ball.center.x less than 5. What's the implication of that logically?
Position with respect to a certain boundary, that it pretty much knows that it's some sort of desired threshold.
Exactly. So recall that 0, 0 is the top left-hand corner. So if the ball goes within 5 pixels of 0, it's really all the way over to the left, at which point I'm just going to say that's a goal. It went over the boundary. So who should get the score? The guy on the right. So score right should be plus plus, because he's the one who would have kicked it into that end. And then I call self kickoff. Well, what does kickoff do? Let's come back to this function and this method in just a moment. Kickoff does a few things. It pauses the game, apparently. It then updates the scores based on what's in the NSU integer. So the unsigned integers are numbers, but I want to turn them into strings so that I can paint them on the screen in terms of those labels. So that's using some building blocks from a few weeks ago. Now I want to center the ball, and I'm going to go ahead and center this at that particular location here. And then I'm going to go ahead and align the paddles, which was just a bit of trial and error, figuring out exactly what made sense on the screen. And now if I scroll back to play, what happens otherwise if there's no goal on the left or on the right? Well, bouncing is kind of an interesting thing. So what is this if condition handling? The highlighted lines are doing what and how? Yeah?
All it's saying is if it hits the top or bottom, all you need to do is switch the direction of the y part of the velocity.
OK, good. So as the comment says, this has to do with bouncing off the top and bottom. But how? Well, if the y coordinate of the ball center is less than 5, that means it's really close to the top. And if its velocity at that point is some value, how do you make it stop going upward? I'll just change the velocity to negative. So if we effectively want to make right angles when we hit the side of the wall, it actually suffices. If, again, you think of the motion as an x component and a y component, if the ball is going up this way, you don't want to change the x motion. Like, you don't want it to go this way, because that would be weird if the ball hit here and then went this way. You want the ball to go this way and keep going to the right, but you want it to start coming down. So all you have to do is flip the y from positive to negative, or conversely negative to positive, and that's exactly what we're doing inside of this if condition. If we get within 5 pixels of the top of that screen, go ahead and flip the y's velocity, as with that negation there in that line of code. And the or is just handling the bottom of the wall as well. And the fact that I'm using a negative sign here means it doesn't matter if the ball is going up, now it'll come down, or if it's going down, now it's going to go up. The left paddle is a little more interesting. And how are we apparently detecting intersection? Well, it turns out in the core graphics library, there's a helper function called cgRect_rect. And you can pass in 2 rectangles, and it will return true if they're overlapping, which is perfect. And this is why I didn't quite make the ball a circle. I decided to be easier to just make it a 10 by 10 square. So this way, no matter where it touches, it's sort of geometrically reasonable to assume that it's going to bounce. And so in this case, if the frame intersects, the frame of the ball intersects the frame of the paddle, then go ahead and inverse the velocity from negative to positive or positive to negative, depending on which paddle you have just hit, if you're on the left or you're on the right. Yeah?
If you would increase the velocity of the ball, would you get a problem at this point?
If you increase the velocity of the ball, would you get a problem? Define problem.
That the ball is already too far, like it doesn't really intersect the
Oh, good question. Yes, so potentially. I have made certain assumptions about the thickness of the ball, the velocity at which the ball is moving, and how frequently I'm firing the clock timer. I could absolutely come up with values whereby the ball could be here at one firing of the clock, and then here at one firing in the clock, and the paddle could have been here in the middle. So that would just be a mathematical mistake on my part, and something that I'd run the risk of if I had variable velocities. But all I'm doing with my velocity here is just inverting it, positive or negative. Good question. Other questions here? All right, so here is my artificial intelligence. If you really want to have basic AI in your game, really all I have to do is tell the paddle to move toward the ball along that y-axis. And so long as he can move just as quickly as the ball, he will never make a mistake. So what am I doing? So if the velocity at which I'm moving is negative, what does that actually mean? If the ball is moving left, so that means it's coming at the computer's paddle. My paddle was on the right for this version. Computer's on the left. So if the ball's moving this way, that's the indicator, according to this code, that the computer AI should start doing something. So if the ball's center y component is lower than the paddle's y component, the paddle should, per the next line of code, move its center toward the ball. Conversely, if the ball's center is higher than the paddle should move up toward the ball. And so no matter what it seems, this paddle will always keep pace with the ball, and really only I, the human, am ever at risk of losing. So let's see if this is indeed the case. If I run this version of the game, we now have 2 paddles on the right. If I click, that's when the kickoff starts. And notice he only moves when the ball is coming back at him because of that check. Though we could add some randomness. If we really wanted to give the human a fighting chance, we could have the paddle keep moving somewhat randomly. We could change its speed. But for the most part, we have a pretty boring game. But we could make it more interesting if we go back here. And what could make it more interesting? How about we change this to 30 points per unit of time? Now if we rerun the program, we'll get a game that's a little harder. And come on. Now if I click, damn it. Damn it. Oh my God. There we go. Thank you. Okay, so it's really hard now. What else could we do? Well, I mean, if you could imagine making this into even more of a game, maybe like a utility app where it flips over, you could change the size of the paddle, kind of like a game Arachnoid years ago, where things get harder or easier depending on the settings. So there's a number of things you can do with this. But at the end of the day, we really didn't write all that much code, right? We asked iOS to inform us when is the movement happening with the touches, so we can respond to that. Then we drew some things in advance, but we've seen that we could totally skip the Photoshop step and just draw these paddles as their own classes, instantiate them, and do something almost identical with the ball, just making it a little smaller. And at the end of the day, the only thing that I'm doing here is I'm borrowing some code from my paddle example. Anytime the touch is moved method is called, and that means something has happened on the glass with a human's touch, I'm going to ask, give me one of those touches, figure out what its x comma y is, and move the right-hand paddle to that side of the screen. So really, the human side of things boils down to just those 3 lines of code. So we have yet another few pieces of building blocks there. So any questions on our first 2-dimensional game?
Mm-hmm. Are you somehow preventing the paddle from being pushed off the screen, or does Apple have something built into this and letting you push the paddle off?
Good question. Am I doing anything to prevent the paddles from pushing off the screen? Yes, I am, in the sense that my code is only ever altering the y-axis of the paddle. I'm only allowing it to move up and down. So notice here, recall this line of code from our previous example. The paddle on the right, his center, is only ever being updated according to the y-axis. So notice this value here, the x value, this is literally the paddle's current x location, because it's self.paddleRight.center.x. So what is your current x location? And the fact that I've pasted that as the first argument to CG_point_make means whatever your x location is now, it's going to stay that way, because that's the new point that I'm making. But location.y is coming from what? From the human touches, based on these 2 previous lines. So in short, this third and final line of code in here is just ensuring that the paddle center will absolutely be able to go up and down, but it will never respond to left-right movements. But we can decouple those. If I go back, just like I did last time, and say, go ahead and let the user have location.x, and now run this. Now this game's, I can't do 30 points per second, 10. Now this game gets a little more interesting in that I have a bit of an advantage where I can just kind of chase this, oh damn it, over there. So that has to do with the refresh rate, so to speak. So now the math is a little off in that I can't assume a certain axis, but now I have decoupled it from that axis.
But I meant on the y-axis. Like, why when you push it all the way up is it not going off screen?
Oh, it is. I'm just stopping. My mouse can't quite pull it all the way up there. But yeah, it's going off the screen somewhat. And we could detect that too, because we know the height of the thing, and we could just ensure that you couldn't go any higher than the glass.
You don't have to safeguard it because you can't click off.
In this case, but if you've ever been bored, like, what do I usually do on my phone? Sometimes when you're really bored in iOS, you can start using your thumbs and like start pulling down on Safari to see how far. So other people have done this, yes? Okay. So someone has checked for that in Safari. We have not checked for that here. So in theory, you could get it to go off the screen and probably get it such that you maybe can't get it back, depending on where it's detecting the finger press. I'm glad that's normal behavior. Okay. All right. Any questions then? All right, so what lies ahead? Well, Evil Hangman is still in front of us. On Wednesday, we're going to take a direction in a lab that's not specifically about the final project because there is no one specification. It's up to you guys to propose this. We'll have the specification posted for it on Wednesday, but it will essentially boil down to come up with an amazing idea, propose it to your TF, and await his confirmation or requests for modifications of the idea. And the request won't be, we don't like your idea. It will be more, we don't think that's realistic in 2 weeks, or we think that's too realistic in 2 weeks, just to give you a sense of calibration so that you can bite off something that you can indeed chew. And what we'll do is try to calibrate you so that you have a threshold, a quality threshold that you'll definitely meet. And we'll also try to push you a little bit to have, say, a good, better, best version of your application, where it'd be amazing if you get the best version, but we'll be quite pleased if you get the good version out the door in time for that app party. So in lab this week, what Chris Gerber will do is introduce you to some more advanced techniques in iOS to further seed your minds with opportunities. Even though the proposal will be due shortly thereafter, realize you can change your mind. If you realize, wow, I love the accelerometer, I really want to do this instead, just make sure to have a two-way conversation with your TF to make sure it sounds like a reasonable change. Why don't we officially adjourn here tonight, and we'll see you next on Wednesday.